Hello everyone. Now this is section 3.3. Again, before I start the lecture, I just want to remind you guys about the exam and also the we've assigned homework. So basically, yes, for this week, for this Saturday, well, this is section 3.3, right? So this is section 3.3. So this section plus the section I covered Monday, Tuesday, right? I made the 3.1 as Monday and Tuesday, both combined lecture, right? So yeah, that section and this section homework, or web assigned homework is due this coming Saturday, which is October 3, 11:59 p.m. Well, I covered section 3.2, but I said that I think I mentioned and also in the video that I am not going to assign any homework from that section, but still you might see some problem from that section, right? Okay, anyway, and also, okay, if you see the schedule, we are right here. Monday, this is Monday lecture, right? So September 28, right? So September 28. Now, our next exam is going to be next week, Thursday. Okay, so for next exam, I will be covering, okay, so this 2.3, 2.4, I didn't include this section for exam 1. So I'm going to include now this section as well for exam 2. So starting from here till here, I will be covering everything, starting from 2.3 till 3.7. So everything that I'm going to cover this week is also going to be in the exam. All right, so now 3.9 and 4.1 will be included on exam 3. Okay, so basically what I'm saying is from 2.3 to 3.7, it's going to be an exam 2. All right, and also if I assign any quiz in this lecture, since this is a Monday lecture, so if I assign any quiz in this lecture, that is going to be due tomorrow. Quiz due is tomorrow. Well, this is a Monday lecture, so that means anything that is assigned is going to be next day, which is September 29. Yes, Tuesday, September 29, 11:59 p.m. All right, so you just have to submit that in the Blackboard like you do every time. Yes, okay, now let's go to 3.3. Okay, so 3.3 here, the first thing I'll be talking here is increasing and decreasing tests. So here, okay, so if f prime of x is greater than 0, so here, when you get the derivative of a function at a certain point, means it is a tangent, right? It is a tangent line at this point. Means tangent line at x, right? So if the f prime of x is greater than 0, so that means if the slope, oops, I forgot to say the slope of, this means the slope of the tangent line at x, right? So if the slope of the tangent line at x is greater than on a certain interval, then f is increasing in this interval. Okay, and if the slope of the tangent line is less than 0 on this interval, then f is decreasing on this interval. Okay, so then let's do an example. Okay, this is given, and we need to find critical number and increasing and decreasing interval. Okay, so here, so we can find increasing and decreasing interval if I can take if I can find the first derivative of f, right? So then, okay, so first we can find the critical number if I can take the derivative of this. So f prime of x is equals to 3 times 2 is going to come down. So 3 times 2, x to the power 2 minus 1 is just just 1, minus 2 is going to stay there. The derivative of x is just 1, so negative 1, which is basically 6x minus 2, right? And then once you get that, okay, now we need to find, well, critical number. So the critical number, we can find that saying that f prime of x is equals to 0. So f prime of x is, well, this one. So 6x minus 2 is equals to 0. So then 6x is equals to positive 2. So x is equals to 2 over 6, which is 1 over 3. All right, so now this is going to be the critical number. So now here, what or how do you find increasing and decreasing interval? Okay, so now, well, we found a critical number, right? So I can plug that here, 1 over 3. So now to find the critical number, so we can pick any point in this region. So this is going to go to negative infinity. This is going to go to positive infinity, right? So any point on this interval and plug that into this f prime of x, right? Because that's what it is saying. If we can get f prime of us at certain point is greater than 0, then we can say in that interval is going to be the increasing interval, right? So let's see. Okay, let's pick any point. So I can pick anything less than 1 over 3 means I can pick 0, right? Because 0 is less than 1 over 3. So, and then plug that into this. And let's see what we're going to get. So here, if I plug that into this, then I get 6, 0 minus 2 is negative 2. So if your f prime at certain point is negative number, or if it is less than 0, then that is going to be, or we can simply write negative here, because this reason we're going to get negative. Okay, similarly, let's check here. If you get negative here, doesn't mean you'll get positive here. You might get both negative and negative, so you have to check it. All right, so that's why you have to show me this work in the exam. You cannot just simply make, well, this is called sign chart. Okay, this chart is called sign chart. So you cannot just simply make a sign chart. You have to show me this work in the exam as well. Okay, so if you just make a sign chart, then I will predict that maybe you got the answer from somewhere, or you just copied the answer from somewhere. I'll think that. Okay, so to convince me that you did all of your work by yourself, you just have to show me the whole work. Okay, and similarly, let's pick any point in this region. Let's just pick 1, which will give 6 times 1 minus 2. And then here you'll get positive 4, right? You'll get this positive. So that means if you get negative, this is going to be a decreasing region. If you get positive, this is an increasing region, right? If you get positive, it's increasing. If you get negative, it's decreasing. So then that means let's just write the increasing and decreasing intervals. Let's just say the decreasing interval, or let me just write D, which means decreasing. All right. So decreasing interval is negative infinity to 1 over 3, right? And increasing interval is this interval, which is 1 over 3 to infinity. Okay, so yes, that's the idea. And here again on the sign chart, this is going to be open circle because we cannot include this point, because this point is a critical number point, right? But anyway, yeah, that's how you find the increasing and decreasing interval using the first derivative, right? We found the first derivative, and then we found the increasing and decreasing interval. Okay, now let's find a local maximum and local minimum. Okay, so what does local maximum and local minimum means using the graph? So here, let's find, okay, let's include one more thing here. Let's find local maximum and local minimum of this example as well. So what we can see from this is, well, since we are saying, and this reason it is decreasing, right? So that means the graph is going to be something like this. It is decreasing, right? If you go from left to right, this graph is decreasing. And from after this point, it is increasing, right? So that means this point is going to be local minimum point, right? Because it is decreasing and increasing. Okay, so the same idea, we've got to use the same idea here. So let's follow all these steps. So, okay, first let's find critical number. So to find the critical number, we need to find f prime. So now if I take the derivative of this, it will be 3x to the power 3 minus 1 is 2. 2 is going to come down here, so 6 is going to multiply to 2, so that will be 12. X to the power 2 minus 1 is just 1, plus derivative of x is 1, so we're just going to have 9. The derivative of 1 is 0, so we don't have to write that. Okay. Now, now we need, so to find the critical number, we need to set this as equals to 0, or this means 3x squared minus 12x plus 9 is equals to 0. Okay, so it looks like there is the common here 3. I can factor that out. So x squared minus 4x plus 3 is equals to 0. So then I will get, so just divide 3 on both sides. So x squared minus 4x, 3 is equals to 0. So we have 3 here, we have 4 here, so it looks like I can use, well, 3 times 1 is 3, so I can use 3 and 1. But there is a negative 4 here, so it will be x minus 3, because we are using 3 and 1, and x minus 1, right? Because negative 3, negative 1 will give negative 4. So that means here I will get x is equals to 1, x is equals to 3. So these two are critical numbers. Okay. Now, okay, now let's make a sign chart and figure out the increasing, decreasing interval, and also let's figure out local maximum and local minimum point. Okay. So let's make a sign chart here. So from this sign chart, well, since we got 1 and 3, so okay, let's say 1 is here, 3 is here. Okay, now let's see if this interval is increasing or decreasing, whether this is increasing or decreasing, or whether this is increasing or decreasing. Okay, so now to find that, well, we can pick any point in this interval. It doesn't matter. So let's just pick 0. So if you plug that into this f prime or f derivative to this, right, then you will get this reason positive, because 3 0 square minus 12 0 plus 9 will be, this is 0, this is 0, so we'll get this positive. Okay, and here you will get, you can again pick any point, so you can just pick 2, plug that to again to this f prime, you'll get negative, and similarly here you'll get positive. You can do that by yourself. Okay. So now after this, well, now we can say that, okay, the increasing interval is Is this decreasing? Well, these two are increasing intervals, so maybe the graph is like this. Okay, so the graph is maybe it's something like this. It's increasing here, and after this it is decreasing, and again after this it is increasing, right? Something like that. Okay, now and now okay, so here let's write that increasing interval, or let me just write I. The increasing interval is from negative infinity to 1, and also from 3 to infinity. And the decreasing interval is, since this, well, you'll get negative in this interval, so decreasing interval d is 1 to 3, right? Okay, now what point is local maximum, what point is local minimum? So if you see here, it is increasing, decreasing, so this point here is going to be local maximum. So that means at 1, it's going to be local maximum. So at x is equals to 1, you will get local maximum. So we need to find that exact point. So to find that point, you need to, now to find the local maximum, local minimum point, we need to plug this into the original equation, f equations, this equations, all right? So plug this in here, so you will get 1 to the power of 3 minus x times 1 square plus 9 times 1 plus 1. So you will get here, this is going to be 5. Okay. And similarly now, well, since this is decreasing and from this point it's increasing, so this is going to be local. So this is local maximum point, and at x is equals to 3, f of 3 is equals to, okay, just follow the same steps and you will get here 1. So this is, or simply you can write, instead of saying that, you can even say local maximum point is x is 1, this is 5, so 1 comma 5 is local maximum, and here local minimum is 3 comma 1. So this is local minimum. Okay. Okay, now next one is concavity. So concavity here, we need to use f double prime. So you need to take the derivative twice. Okay, so here since we have two lines here, so that means we're taking derivative twice. Okay, so if f double prime is greater than 0 on certain interval, then we can say f is concave up. So the concave up means something like this. Okay, and if f double prime is less than 0, then it is going to be concave down, something like this. Or you can even say this or something like this. This means concave upward, and this means concave downward. Okay, something similar to this kind of graph. Okay. Okay, now okay, now let's do an example. Okay, so here, and also, oh, sorry, one more thing I forgot to mention. So inflection point. So inflection point is a point where curve changes from CU. Okay, CU means concave upward, all right, and CD means concave down. So from concave upward to concave downward, or from concave downward to concave upward. Okay, so that point is called inflection point. Okay, so there is a way of finding inflection point. So again, to find the inflection point, well, let's just follow this all of these steps. So that way we will be finding we'll be finding inflection point, and also we will be finding concave down and concave upward intervals. Okay, now, okay, let's first find a critical number. So again, to find the critical number, we need to find the derivative, or f prime, which will be the 4 will come down, and x to the power 4 minus 1 is 3. 3 will come down here, so 4 times 3 is 12. X to the power of 3 minus 1 is 2, right? Okay, now here after this, we can say f prime of x is equals to 0 to find the critical numbers, right? So then f prime of x is also this, so 4x to the power 3 plus 12x squared is equals to 0. Now from these two I can factor out 4, right? First 4 and 12, well, I can factor out 4, I can factor out x cubed, and x squared, I can factor out x squared, then x plus 3. These are the remaining terms, right? So then I can say either 4x squared is equals to 0, divide both sides by 4, so still x squared is equals to 0, or x is equals to 0. Or x plus 3 is equals to 0, so x is equals to negative 3, right? Okay, now after this I can find local maximum and local minimum, and also I can find increasing and decreasing intervals. So again, make a sign chart. Okay, so we found two critical numbers, 0 and negative 3. So negative 3 must be here, and 3 must be here. Sorry, 0 must be here. And then, so again, take any points in this interval, okay, any points, and plug that into the original equation. Oh, sorry, not originally. Plug that number to this f prime. So f prime already found here, right? So if you plug that to there, let's just pick negative 4. Okay, so negative 4 is going to be on this region, and if you plug that to here, well, here you'll get some negative number. You can do that by yourself, but you'll get negative numbers. So that means this region is going to be negative. Okay. Similarly, you can pick any point in this region. You'll get this region positive. Similarly, if you pick any points in this region, if you just let's say 1, you'll get this region. What do you think? You get negative here, you get positive here. So do you think we should get negative here? No. Like I said, like I mentioned before, if you get negative, positive, doesn't mean you have to get negative here. You might get positive here as well. So here, if you pick any point, let's say 1, doesn't matter any point in this region, well, here you'll get positive in this case. Okay. So that means our increasing interval is going to be from negative 3 to 0. That's one interval. And also from 0 to infinity. Oops. All right. And the decreasing interval is from negative infinity to negative 3. Okay. So here, you must show this work in the exam. I have skipped here. I expect that you guys will be doing it by yourself. I just gave you the answers. Since this is algebra, so I expect you guys to do it by yourself. All right, so there is nothing complicated here, but in the exam, you cannot just skip your work like this. You have to show me the whole work. All right, you have to show me this whole work. Okay, now after this, okay, so now it looks like, that means it looks like the graph is going to be, okay, so on this interval, it's decreasing, right? And from here, it is increasing, right? And again, after this, it is increasing, something like this, right? So from here to here, it's decreasing. So our graph, it's just the estimated graph. This is not exact graph, okay? But this is the estimated graph. So it's going to decrease, increase, increase, something like this, right? Okay, now, so that means at this point, so here, do we have, okay, so it looks like this is decreasing, increasing, increasing. So that means this point, at this point, at x is equals to -3, we will get local minimum, right? So that means now we need to plug this into the original equation, or to this f function. So plug that into the original equation, 3 to the power, or -3 to the power 4 plus -3 to the power 3, right? So here again you'll get this -27. So that means -3 comma -27 is local min. All right, so now in this problem we don't have local maximum, because here it's increasing and it's increasing. All right, so it's going to increase to the infinity. So there is no local maximum point in this problem. All right. Now, okay, now here we need to find, so for these things, we used f prime, right? We used first derivative. Now for this one, we need to use second derivative, right? So, okay, now let's find the second derivative. So first derivative we found here is this one. So using that, I can find the second derivative. So the first derivative, okay, oops, let me write that here first. So first derivative we have is 4x to the power 3 plus 12x square. So now if I take the second derivative, then I get, okay, 3 is going to come down here, so that will be 12 x to the power 3 minus 1 is 2. 2 is going to come down here, so 12 times 2 is 24. X to the power 2 minus 1 is just 1. Okay, now to find the inflection point, it's pretty similar to what we did for the critical number. Okay, so now once you have the f double prime, again said this is equals to 0. And then now f double prime is also this, right? So 12x squared plus 24x is equals to 0. And then now I can factor out 12, right? Number from 12 and 24, I can factor out 12. From x squared and x, I can factor out x. So the remaining terms are x plus 2. So that means x is equals to 0, or x is equals to -2, right? Okay, now after getting this, oops, okay, after getting this, now let's draw a sign chart for this one. So now here we found -2 and 0 again. So just like we did for increasing and decreasing, take any points in this interval and plug that into now to f double prime. So let's say if I pick -1, then plug that into f double prime, which is 12 times -1 square plus 24 times -1. So here you will get, this is 12, this is negative 24. So you'll get negative number, right? So negative 12. Oops, no. So I picked this reason. So -1 is basically for this reason, sorry. So this reason is going to be positive, negative. Now, for this reason, I'm sorry, I have to pick something like -3, -4, right? So if you do that here, you'll get, now this one you should get positive. Okay, and similarly, you have negative here, sorry, you have positive here, negative here, doesn't mean you should get positive here, but in this case, you'll get positive. You might just get everything negative as well, okay? Okay, so you get negative here, sorry, positive here, negative here, so that means if you get positive, okay, if I mentioned this all the way down here, so if you get f double prime positive, then in that interval, you will have concave upward if it is positive. If it is negative, that region will be concave downward. So then that means this region is, so the concave upward region is, CU, concave upward is from -infinity to -2, and also from 0 to infinity, right? So 0 to infinity. Similarly, for concave down, you will get from -2 to 0. And so here, these 2 points here are going to be inflection. Okay, so why we can say this in inflection point is, like I said, the inflection point is a point where concave upward is going to go to the concave downward. So here, this, from here to here, it's concave upward. So after this point, it changed from concave upward to concave downward. So that's why we can say this is inflection point. And similarly, from here, it's concave downward, and it's after that, it's concave upward. So that's why this is also inflection point. Okay, so you cannot simply say inflection, these are inflection point just by getting these 2 numbers, just like we did for critical number. Critical number is different. For inflection point, you need to follow this process. Let's say if you get this negative, this positive, let's say this is -1, negative, this is 3, then here we have a negative, here we have negative. So that means this is not inflection point, because here we're still here, there's still a concave downward, right? So that's why this point is not going to be inflection point. But here, yes, because here we see the sign changes, right? Okay, so you got an idea how to find the inflection point and concave upward and concave downward, right? Now, okay, now another one is finding local maximum and local minimum using second derivative test. Okay, so here we found we found local maximum and local minimum using first derivative, right? So if I mention in the exam, okay, find local maximum and local minimum using second derivative test, then you have to use second derivative test. Okay, you must use second derivative test. If you don't use second derivative test, then probably you won't get full points, or maybe you'll just get 0. Okay, let's do an example. Okay, so now here you have that if we get the second derivative at C, where C is a critical number. So at C, if we get the double derivative greater than 0 or positive, then at that point, we're going to get local minimum. right? Just be clear. If it is greater than 0, then it's local minimum. If it is less than 0, then it is local maximum. Okay, so let's do an example here. So again, here we need to find, okay, here we need, so we need C, we need critical numbers. So to find the critical numbers, obviously we need to find the first derivative, and also we need to find the second derivative, right? So, okay, let's do that. So f prime of x is going to be 3 is going to come down here. So 3x to the power of 3 minus 1 is 2. 2 is going to come down here, so that's going to be 18. X to the power 2 minus 1 is just 1 plus 24, right? So then now to find the critical number, okay, we can say f prime of x is equals to 0. So then we get 3x squared minus 18x plus 24 is equals to 0. So now factor out 3, so x squared minus 6x plus 8 is equals to 0, right? Now divide 3 on both sides, so we just have x squared minus 6x plus 8 is equals to 0. Okay, now from here we get 8, so that means I can say 4 and 2, right? Because we have 6 in the middle, so that means x minus 4 and x minus 2. So minus 4 minus 2 will make minus 6, right? Okay, so that means here we get x is equals to positive 4 and x is equals to positive 2. Okay, now after this, uh, after this, uh, okay, after this, okay, what we can do after this. So now to find a local maximum and local minimum, now taking these 2 points, if we get f double prime at that critical numbers, if you get that positive, then it's local minimum, right? So let's take this point. So at x is equals to 4, f, okay, we haven't found f double prime, right? So let's find that first, and then we can say that. So f double prime is going to be, so from this, bring this 2 down here, so that will be 6x to the power 2 minus 1 is just 1 minus 18, right? So that's f double prime. So, okay, from that, now I can say that, okay, so since we have these two, so at x is equals to 4, f double prime of x is 6 times 4 minus 18. So you will get 6 times 4 is 24. 24 minus 18 is 6. So since we get positive, so if we get positive, then it's local minimum, right? So local minimum point is going to be f. So now take this, sorry, take this 4 and now plug this 2 now to the original equation, okay? And do that, and you will get that as a local minimum, right? So find that. So let's make this a quiz problem, right? It's a simple one. Plug this 4 to the original equation. So that means 4 comma something will be local minimum point. Similarly, now next one we have is at x is equals to 2 plug this into F double prime, you'll get something, and you will know whether that point is going to be local maximum or local minimum. So that means now take that 2 again and plug that into the original equation. So that way you'll get 2 comma something, that number here is local something. Okay, so here find this, here find this. So here this number is going to come here, find this, and this point is going to be local something, find that as well. So this is going to be your quiz problem. All right, I explained everything. It's just that you have to use this thing. Okay, so do that by yourself, submit it by tomorrow. This is a quiz problem, whatever I have a question mark here. So if you see question mark, that means you need to find those things, right? Find that. Okay, that's going to be the quiz problem. All right, so yeah, that's all I have for this section 3.3. Okay, and make sure you do the homework for this one as well by this Saturday, and also the last week section 3.1 as well. Okay, I will see you on next video. Okay, one more thing before I go. I just want to talk about my office hour. I'm thinking to change my office hour is basically Monday and Thursday, right? It looks like I will be slightly busy on Monday. So I'm thinking to change it to Tuesday and Thursday. The same time, 5:30. Okay, Tuesday and Thursday. So maybe I am not going to be there on Monday, starting from this week. Okay, so I will be available through Zoom on Tuesday and Thursday this time. Okay, all right. Anyway, I'll see you on next video. Thank you.